Hello there and welcome to my YouTube channel. Today we are going to be looking at scalars and vectors. Okay, we'll take a deep dive into it right now. So scalars, what are scalars? Scalar quantities are quantities that have magnitude but they don't have direction. Okay, they are quantities that have magnitude. They have magnitude but they don't have direction. For example, let's look at mass, for instance. Mass is a scalar quantity. You can have something like this 10 kg. Okay, the 10 kg here is the magnitude. It's the magnitude. So, scalar quantities like this have no direction. Other examples of scalar quantities we have temperature, we have temperature, we have temperature, we have speed, we have distance, we have length. Okay, all these do not have any form of direction attached to them. So mass, scalar, temperature is scalar. Temperature you can only have something like 100 degrees Celsius. Okay, there's no direction attached to temperature. Speed does not have any direction. 15 kilometers per hour, that tells you the speed at which a body is going. It does not tell you direction. Actually, what differentiates speed with velocity is basically direction. So velocity is a vector quantity. We'll talk about vectors when we get there in a moment. The distance is just the gap between 2 points. There is no direction to distance. Okay, there is a thin line between distance and displacement, and that thin line is direction. So displacement is distance with a specified direction, and distance does not have any direction whatsoever. Now length is length. It has magnitude but not any form of direction. Okay, so there are many other scalar quantities we can look around. Energy, all forms of energy are scalar. All forms of energy are scalar. And these kind of questions most notably comes out in JAM, where you are asked to find a pair of scalar quantities or a pair of vector quantities. When you see this, all forms of energy are actually scalars. Alright, so let's take a dive into, we'll look at vector quantities very quick. And after looking at what vector quantities are, in the next video I'll be telling us how we can calculate vectors, okay, because we don't add vectors the way we add scalars. Let's look at vectors. Vector quantities, these are quantities that have both magnitude and direction. Vector quantities are quantities that have both magnitude and direction. For example, let's say velocity. We have velocity, we have displacement, we have electric field, we have acceleration, force, momentum, among others. Okay, so these are all vector quantities. Notably, I was talking about speed and velocity earlier. Velocity is speed but with direction. Displacement is distance but with direction. Okay, electric field, around a field you have field lines traveling. Okay, magnetic field is also a vector quantities. Now, what do I mean by magnitude and direction? Let me quickly bring something into perspective. For example, say we have a velocity 50 km per hour north, 30 degree east. Okay, this here tells us of the magnitude, and this here tells us about the what? The direction. So that's why we call velocity a vector quantity. Displacement, electric field, acceleration, force, momentum, magnetic field. There are others like we have tension, we have torque, we have moment, yes, movement of a force, and among many others, and many examples, a plethora of examples. Alright, so scalars can just be added by normal arithmetic method, whereas vectors are added geometrically. Okay, vectors are added geometrically. So in our next video, we are going to talking about how to add vectors. We are also going to look at the resolution of two vectors, and we are going to look at the resolution of two or more vectors. Look at resolution of coplanar forces. We are going to look at resultant vector. So join me in our next video.